All right, here in lesson 1.5, we are going to look at graphing sine and cosine values, and this video is going to get you through both days. Say the first day, we're just going to focus on, say, something called amplitude and period, and then kind of the second day is more of a, say, adding in something called a phase shift and a vertical shift, and then looking at how we can maybe model, say, real world situations, say with some, say, sine, cosine value or functions. And so with sine and cosine, say they're what we call periodic functions. So they repeat over and over and over. And so their graph is just kind of they look like a wave, say up and down, up and down, up and down. And they look really similar to each other. There's just kind of one main difference with how they start. But essentially what this function is doing is it's just plotting our unit circle values over and over and over. So like this part here is the top part of the unit circle. And then this part here is the bottom half of the unit circle, so to speak. With sine functions, and actually cosine functions too, the domain is all real numbers, so you can plug in any angle. But then with the base sine function and cosine function, it reaches a height of 1 and goes down to -1. And this piece here, that height from this middle line, that is what we call the amplitude. Say it's how high or how low a graph gets. And then how long it takes for our graph to repeat is what we call the period. So the base sine and cosine function repeat every 2 pi radians, or every 360 degrees. Okay. So when we get to actually graphing them, we're going to find like 5 key points, because with a sine function, it always starts kind of in the middle here at this kind of, if you want to call it the x-axis, we can call it the x-axis. Say for day 1, or for the first part, it actually is the x-axis. It might just shift kind of when we get into day 2, when we start talking about, say, vertical shifts. But then if we take that period length, whatever it is, and we divide it by 4. So if we take our period divided by 4, that's going to give us 4 equal chunks here. Okay. And at each one of those kind of key points, our function is either going to hit its maximum value, intersect this x-axis, hit the minimum value, or again, intersect that kind of x-axis. Okay. Say this is what a base sine function would look like. One thing I did want to mention here, okay, just because I don't know if I got an example on this, if I were to take kind of that same, let's call this 0, 1, -1, let's go 0, end at 2 pi, pi over 2, 3 pi over 2. If I were to switch it from sine to negative sine, so just throw a negative in front there, then all that's going to change is, instead of starting in the middle and going up to begin with, what it's going to do is it's going to start in the middle, but then it's going to go down to this minimum value first, and then come back up to that middle line, and then hit my maximum, and then come back down, and it'll look something roughly like that. Okay, so positive sign starts in the middle, goes up. Negative sign starts in the middle and then starts down. Okay, and there'll be similar kind of difference with cosine, kind of as far as like how it starts. And so with the cosine function, it's going to look almost identical to a sine function, just shifted a little bit. And so you could either look at it as like a sine function, like shifted left or right, or almost like a sine function with a different starting point. So with a cosine function, if we're dealing with positive cosine, rather than starting in the middle here at 0, okay, or the x-axis, like a sine function, all it does is it starts at the maximum, and then at that first kind of key point, so a quarter of the way through the period, it comes down, hits that x-axis, then it keeps going, hits that minimum, comes back up, and then it ends kind of where it starts at the top there, and we get that sort of a, again, still a wave function, a wave graph, okay, that sort of thing. Similar to like sine, if I were to switch it from positive cosine to negative cosine, okay, I'll keep everything else the same, so that's 0, pi over 2, pi, 3 pi over 2, 2 pi, 1, negative 1. Again, the only difference, instead of starting up here with a negative cosine, we're going to start at kind of our minimum value. So not up there. So start at the minimum, and then this will go up to the x-axis, hit the maximum, come back down, and then again end where we started and get something. Basically, say the other graph just flipped kind of upside down, more or less. Okay. So then we'll look at how we find, again, those kind of key 5 points there. The length of time, or the number of degrees that it takes for a sine or a cosine function to repeat. So the period length can change. It's not always 2 pi. It's sort of 360 degrees. And the amplitude isn't always 1. Those are kind of determined by a couple things that'll kind of come in the equation, and we'll get there here in a sec. But for the base sine and cosine functions, say our period is always 2 pi, say our amplitude is 1. Okay. The things that control amplitude and period. Okay. Amplitude is probably the easier of the two. Amplitude is just determined by the number in front of the sine or the cosine part. Okay. The absolute value of A is going to be how high or how low your function gets. Okay, so if I had a function that was y equals 2 sine x, and my amplitude is going to be 2, and when I like set up my graph, I know it's going to go up to 2 and down to negative 2. So it'll go up a little bit higher, down a little bit lower. Okay, if it was 1/2 sine x, well then it's still going to kind of follow the same path. This is just going to be much more kind of shallow. Okay, because I would only go up to 1/2, down to negative 1/2. Okay, because my amplitude would be 1/2. Okay. So then we already talked about kind of positive, negative. So again, positive sine starts in the middle, goes up. Negative sine starts in the middle, goes down. Positive cosine starts at the top, then goes towards the middle. Negative cosine starts at the bottom, so then goes, still again goes towards that x-axis, goes towards the middle there. Okay. The thing that controls the period, say, is predominantly what we call the b value. Okay, this thing here, so it'll be the number in front of the x or the theta or whatever your variable is in your sine or cosine function. Okay, we have this c here that it affects the period in a way, but it's going to be more of a kind of second part of the assignment. That comes into play in what we call a phase shift. So it doesn't affect the length of the period, it just kind of affects where the period starts and ends. Okay. Now, the role that this b value plays is we have this little formula here that says the period of a sine or cosine function is 2 pi divided by b. And if we're being technical here, it should probably be the absolute value of b, because our period should always be a positive. Now, if you are somebody who would rather work in degrees, you could kind of tweak this formula, because 2 pi is the same as 360 degrees, we could go 360 over the absolute value of b, and that'll give us our period in terms of degrees. So if that's easier to work with, we can try to do that. So we can maybe look at kind of a case for both, because there might be times when keeping it in terms of radians might actually be easier. So I'll maybe try to highlight when that could be. Okay, so if b is less than 1, or if it's between 0 and 1, what that's going to do is it's going to increase your period length. It's going to be greater than 2 pi. But if b is bigger than 1, then it's going to shorten your period length, saying your wave will repeat more often. You'll get more kind of mins and maxes and more kind of a higher frequency, so to speak. Okay. And so here's kind of a couple kind of quick examples of just what some different things would kind of do. So if we've got, again, 2 sine x, it changes our amplitude up to 2 and down to -2. And then if we were to take our 2 pi over our 0.5, say is our b value in this case, that would end up getting you basically 2 pi times 2 is 4 pi. And so if we look at where we start and where we finish, that is a distance of 4 pi, okay, rather than the typical 2 pi that we would normally kind of have there. Okay, and then if we had 2x, or if we had a b value of 2, if we did 2 pi over 2, well, that's going to get us a period of pi. So our original kind of sine function is the dotted one here. But with the 2x there, if I look at where we start, and if I go one repetition or one cycle here, so I go up, down, back to the starting point, that distance there is a distance of pi. Okay, so if b is bigger than 1, shortens your period. If b is less than 1, say it lengthens your period. Okay. Okay, and again, a couple examples, just like identifying period and using or finding your period length. The one thing I did kind of want to mention here real quick, with like when to maybe keep things in radians or when to convert to degrees. If you're given a b value, so in this case it'd be pi over 2. If you're given a b value that's got pi in it, I think it might be a better idea to keep that in terms of radians, because if you were to do 2 pi divided by pi over 2, that would be the same thing as 2 pi over 1 times 2 over pi. So if you were to kind of rewrite this top part as 2 pi over 1, we're basically taking top fraction times the bottom fraction flipped. Okay, if keep change flip rings a bell from middle school, or multiplying by the reciprocal is like technically the mathematical way we would say that. That's ultimately what we're doing here. And in this case, say pi and pi can cancel, and so we get a period of 4 radians. Okay, which honestly is probably easier to work with than in degrees, because degrees, that's going to be like 228 point something degrees. Okay, not real great to work with. So if you're given a b value that has a pi in there, it might be better to keep it in radians. Okay. And again, same thing there. If we want to actually get to kind of examples where we're actually graphing things. So if we take just a function y equals 3 times sine of 2x. So something where we get an amplitude that's different and a period that's a little bit different too. My amplitude in this case is just going to be 3, because again, it's just that number in front of my sine or cosine function. If my b value, again, because b is this 2 here, if it doesn't have a pi in it, this might be a case where turning it into degrees might be a little bit easier to work with. Okay. Because if we take 2 pi over 2, we could get it in terms of pi, and it'd be pi radians, and that's fine. Or if I went 360 degrees divided by 2, that's 180 degrees. And so I went in terms of degrees here. And so if I'm starting at 0, okay, what you can do is if you take 180, again, your period length, divided by 4, that's going to give us, in this case, 45 degrees. That's essentially telling you what you should add to get the next kind of value on your x-axis, to find those kind of key critical points, okay? So if I start at 0, add the 45, 90, 135, 180, then I'm going to get that full period length of 180. And if I kind of went the same way this way, 0 up to negative 180 is another 180 degrees. Say the one little kind of misstep I had here, so if I can try to fix this real quick. Say with my amplitude being 3, I should have my amplitude coming up to 3, and I just had 2, so let me just throw like an extra dash in there to make this 3. And negative 3, just so that it actually is kind of representing what I want it to. But then, again, with sine, I'm starting in the middle, and since it's a positive sign, I'm going to go up to my maximum at that first kind of critical point. I'm going to go down to that x-axis in the middle. I'll hit my minimum at kind of the third one, and then I'll end up right back in the middle there at the very end. And then I would kind of go a little bit kind of in the opposite way. If I'm going to the left, I'm going to go down to start with, and then back up, and then hit the maximum, and come back down. Okay. Okay. So there's a sine function. If we switch it to a cosine function, okay, again, not a lot is going to change. Our amplitude is still the number in front of our cosine. Again, I would just write it as the positive, so even though it is negative 1/2, my amplitude is still positive 1/2. My period, in this case, again, since I'm given my b value is 2 pi over 3, then what we're going to do, or what I'm going to do, is I'm going to keep my period in terms of radians. So I'm going to go 2 pi over 3. Just like before, I'm going to multiply by the reciprocal. Okay, so I'm going to go 2 pi times 3 over 2 pi. Nice part here, the whole 2 pi's can cancel, and I get a period of just 3 radians. And so if I kind of sketch out this graph here, okay, usually we start again in the middle at 0, and for now we will. That'll change a little bit later, potentially. Again, if I take that 3 divided by 4, that gets me 0.75. So that is how I'm going from here to here, here to here, here to here, and kind of so on. So you could either do that, or you could say, okay, I'm going to start at 0. I know my full period is 3, and then work your way backwards. Okay, halfway is 1.5. Halfway between 0 and 1.5 is 0.75. If that works for you, go for it. Say whatever clicks in your brain. Say that's the most important thing. Okay. Now, with cosine, again, cosine's either going to start kind of at the maximum or the minimum. And if we've got negative 1, well, our amplitude is a half. So that means I'm either going to start at a half or negative a half. And since it's negative 1/2 cosine, I'm actually going to start down here. Let me see if I can get rid of that. Okay. And then with cosine, if it starts at the minimum, it'll go up towards the x-axis, hit its maximum of a half in this case, come back down, and then end kind of where it started at the bottom there. And it would do the same thing, kind of go on the left, go towards the middle, at the top, come back down, and then end there. Okay. Again, if it had been a positive cosine, all I'm going to do is start at the top. So start at positive a half, but then still go towards the middle, hit the minimum, come back up, and then end kind of at my maximum value again as well. Okay. So there's kind of base sine, cosine functions, maybe a little bit different amplitude, a little bit of a different period from time to time. Our assignment kind of for that one, say, is going to be worksheet 1.5 part 1. So there will be a part 2 kind of coming later. Saying with part 2, so we're just going to build off of that. So I'm going to kind of try to keep this in the same video. So with kind of day 2 of graphing sine and cosine, like I said kind of earlier, what we're going to do is we're going to add in things called phase shifts and vertical shifts. So we're just going to kind of change the starting point of our graph. So we're going to move it left, right, up, down. A phase shift is just moving things left and right. A vertical shift is just moving it up and down. And so here would just kind of be a little bit of review of what we just did with kind of base sine function. So we have a negative sine, 2 pi over 3. Again, if I've got a b value of 2 pi over 3, I'm going to keep my thing in terms of radians. So that's, again, where I'm getting that same kind of x-axis as the last one. And again, sine starts in the middle. And then since it's negative sine, starts going that way to begin with. But if we want to actually start translating things, so shifting things left, right, up, down, that's when this C value and D value are going to kind of come into play. So the C value is going to affect things on a left-right basis, and then the D value is going to affect things on an up or down, say a vertical way. And it's same thing with cosine. So C affects it left, right, D is affecting, say, vertical up, down, okay? The nice part with vertical shifts, so with your, say, D value in your equation, that is more natural in that if it's a positive D value, it's going to shift your graph up. If it's a negative value, it's going to shift it down, okay? Like I said, hopefully kind of natural. With a phase shift, it's actually opposite of what you would generally think. So if you were to see like a XY coordinate with like a negative value. So if I had like negative C, normally we would think on a graph, negative takes us left in terms of left or right. Okay, we would think it either goes left or down. Okay, within these left-right kind of translations, so I'm going to write it down here. If I have a minus C, that is actually shifting it right C degrees or C radians. If it's a positive C, we are shifting it left C radians or degrees. Okay, so that one's a little bit backwards from what we would normally think. Okay, again, vertical up, down is normal. Say C values, phase shifts, horizontal shifts, whatever you want to call them, so they're a little bit backwards. Okay, so all of those things combined, because we could have something that maybe has a different amplitude, maybe has an adjusted period if it's not 2 pi. We could have a phase shift and a vertical shift. We could have all of these things happening kind of in the same equation or in the same function, and we want to be able to handle all of them. We're not guaranteed to have all of them. So we might only have 2 or 3, or maybe it's only 1. But we want to kind of look at things that have multiple. So this first one here has every single thing we'd have to kind of worry about. Okay, we got y equals 2 sine, and then in parentheses are 4x minus pi over 4 minus 2. So if we kind of try to identify things, that number in front, that's our a, that's going to affect our amplitude. This 4 in front of the x, that's our b value, that's going to affect the length of our period. This pi over 4 is going to be our c value, that's going to affect the left-right shift. And then this minus 2 at the end, that's our d, that's our vertical shift, up, down. So just like in the first part of this video, so our amplitude with that 2 in front is going to be 2. And then our period, since I'm not given the period with like a b value of pi, I'm going to turn it into degrees. So I'm going to go 360 divided by 4, because that's my b value. That's 90 degrees. Okay, so that's my period. Now this phase shift with the pi over 4, if my period is going to be in degrees, I'm going to want my phase shift or my left-right shift in that same unit. So I would want to switch that pi over 4 into degrees, which is 45 degrees. So that's where I'm getting this phase shift of right 45 degrees. Okay, and then that minus 2 is telling me it's getting shifted down 2. Okay, now the pattern of a sine or cosine function doesn't change based off of this. It's just the starting point. So I'm just going to shift it from, instead of maybe starting at this point right smack dab in the middle, I'm not going to start there. I'm going to shift it down to and right 45 degrees. So this is where we started kind of with our first few examples. Well, if I go down to right 45 degrees, this is kind of now my new starting point. Okay. And then from there, what I did with this blue dotted line is I just used that as like kind of my new middle value. Okay, that's what my function is going to kind of oscillate between. So if I'm starting here, sine, positive sine starts going up, hits the maximum. Okay, and because it's an amplitude of 2, I'm going up 1, 2, and then I come back down. And then if I were to kind of keep that pattern going the other way, I go down 1, 2, hit my minimum, and then I come back up to that middle line. So like there's one full cycle, and then if I kept going, I hit my maximum, back down to that middle, hit the minimum, come back up to the middle, and that should be like 2 full cycles. If I wanted to kind of go, I kind of have a half a cycle going to the right and 1.5 going to the left. If this is my starting point, I kind of have a half a cycle this way, like 1.5 cycles that way. Okay. Now that is one way that you could graph a translated sine or cosine function. That would be if you wanted to move every single point and keep your kind of coordinate plane the same as what it would normally be. Okay, and if that makes sense to you, that is perfectly fine. What I have seen some other kind of textbooks or things do, rather than shifting every single point, what they do instead is relabel the graph to try to kind of account for the translations. So if you wanted to do something different here, okay, and whatever makes more sense in your brain, okay, this is going to allow you to kind of keep things more centered on kind of your like T-chart thing that we've been using. All we're going to do is we're going to, instead of labeling this middle 0 every single time and always having this kind of represent 0, we're going to label things differently. So if we needed to shift things to the right 45 degrees, well, if I went from 0 to the right 45, that would be a positive 45 degrees. So now this middle part I'm saying is kind of representing 45 degrees. And then if I wanted to shift it down 2, okay, all I did was put a minus 2 here. So then this kind of horizontal line represents -2 versus actually representing the x-axis. Okay, so I know it looks maybe a little bit weird. And then kind of to handle my amplitude and kind of being paired with the vertical shift, I labeled this top part 0, because if I'm at -2 in the middle here, my amplitude is 2. Well, -2 up 2 would be 0. So I just have to be a little bit more careful there. And then same thing, if I started at -2 here, went down 2, that would be -4. So I just need to be, again, a little bit careful with that part. But you could relabel all of that stuff, and then all of a sudden, it's just graphing it the exact same way. So like sine starts in the middle, goes up, back down, hits the bottom, and back up. And then again, kind of this way, goes down, middle, up, down. Okay. So whatever way works better in your mind, that's the main thing. Okay, do what works for you. Okay, I don't care one way or another. If we're being technical, to say this way up here is probably the more like official mathematical way to do it. But again, I have seen things do it like this on the bottom. So for me, either way, you have to still know what's going on as far as shifting things left, right, up, down, that sort of stuff. And that's the main thing I'm kind of worried about. Okay. So now if we do one similar, kind of, but with a cosine here, so we've got y equals cosine pi x over 2 plus 1. Well, here we really only have two things that are really kind of changing, okay? Because we don't have a different amplitude. If there is no number in front of that sine or cosine, you can assume it's 1. Okay, so our amplitude in this case is 1. So we don't really have anything to worry about too much there. In this case, we don't have a c value. Okay, if there are no parentheses, like if this was parentheses around that plus 1, then all of a sudden this becomes the c value. But since there are no parentheses, that would be our d value. So that's going to be our vertical shift. So in this case, there is no phase shift, which is kind of nice. So the phase shift is probably the trickiest thing to kind of work with. But in this case, I am going to keep my period in terms of radians because I've got a b value of pi over 2. So since I've got that pi in there, it's maybe going to make it a little bit easier to keep it in radians. So if we figure out 2 pi divided by pi over 2, that's going to be equal to 2 pi times 2 over pi. Our pi's can cancel, and 2 times 2 gives us 4 radians for a period. And then, like I said, phase shift, we don't have one in this case. Again, you're not always going to be dealing with everything. So as far as phase shift, vertical shift, amplitude, period changing, all that stuff. Okay, so we got no phase shift. And then again, our vertical shift is up 1. And again, I've got it graphed the two different ways. So this first one, again, is probably the more like official mathematical way of like shifting all the individual points. So that vertical shift is kind of where that green line is, or green dotted line is coming in. So that's 1. So that's a y value of 1. So that's shifting everything up 1. Okay. And then cosine, and now in this case, positive cosine. So if this is kind of my middle, positive cosine starts at the top and then goes towards the middle, hits the bottom, comes back up, and ends where it starts. And again, my period was 4 radians, so 0 up to 4 is a distance of 4. Okay. And then going this way again, boom, down to the middle, hits the bottom, back up, back to where we started. And we could double check, hey, if this middle part is a value of 1, then maybe we label this 2, just to be clear that, okay, this amplitude is 1. So just to maybe be a little bit clear on that. But again, that's one way we could do it. Say the other way, if we just wanted to like relabel things, okay. So if we're going to take care of that vertical shift, I'm going to label this thing 1. So this is now kind of my middle value. If my amplitude is 1, then my y values are going to go up to 2 and down to 0. So I'm just going to be careful with labeling those things clearly. And then I had no phase shift, so I can still keep 0 in the middle, go 1, 2, 3, 4, -1, -2, -3, -4, and then graph it the same way. Start at the top, go down, and just like before. Okay. So again, you don't have to do it both ways. I just wanted to show you kind of two different ways that people maybe try to handle phase shifts, vertical shifts, things like that. So go with what works for you. That's the main thing, is having it make sense for you. Okay. So then the last thing that we've got here, and if you're this far into the video, I appreciate you kind of sticking with me. I know it's like getting 2 days into one, it makes for a long one, but say we can try to model some real life situations with these periodic functions, sine, cosine. So we got a person at rest. The velocity v in liters of airflow during a respiratory cycle is v equals 0.85 sine of pi t over 3, where t is the time in seconds. Inhalation occurs when v is greater than 0, and exhalation occurs when v is less than 0. Okay, so if we want to identify a, b, c, d, in this case we don't have a lot. So we do have an a value of 0.85. We do have a b value of pi over 3, but we don't have a c, we don't have a d. So that means we don't have any phase shift, we don't have any vertical shift. And so if we want to find the time it takes for one full respiratory cycle, so we can find the period like normal. We can do 2 pi divided by our b value, which again, since it's pi over 3, I'm going to keep it in terms of, in this case, it would be seconds, okay? But I'm gonna keep it as the 2 pi, so I'll go 2 pi divided by pi over 3, which, like the last couple that we've kept in terms of pi, 2 times 3 is going to get us 6. So that's telling us that each cycle here is going to be 6 seconds. And then if we wanted to find the number of cycles per minute, we could set up a proportion where if we know one cycle is equal to 6 seconds, we could say 1 over 6. And we're trying to figure out how many we have in 60 seconds, so I could say that's equal to something over 60. Well, a couple ways that you can solve that. You can either cross multiply and divide, or if you're able to see, okay, 6 times 10 gets me 60, so then I'd have to do 1 times 10, and that's going to tell me that I get 10 respiratory cycles in 60 seconds. Okay. And then the last part, say just to sketch that real quick. So again, we got no phase shift, no vertical shift, so we can keep it kind of 0. Say on the x-axis there, I went with the period of 6 seconds. So if you did 6 divided by 4, that gets you 1.5. So that's where these numbers are kind of coming from. Okay. And then since our amplitude is 0.85, say I just tried to get kind of as close to 0.85 kind of estimate. So I didn't quite get all the way to 1 with the upper and the lower kind of values there. Say, could I have just like said, you know what, let me label this top part 0.85 and kind of done the same thing down on the bottom? Yeah, you could have. Absolutely. That works. So I just wanted to try it this way, say this time, but so hopefully that makes a little bit of sense. Again, like I said, I know, say trying to do 2 days worth of stuff in one video makes for a long one. So, so hopefully you maybe took some breaks in there in the middle there. But if there's anything at all that I went through too quick, please let me know. Okay, I'm here to help you out. But our assignment for kind of day 2 is just going to be the second part. So of that 1-5